Hello viewers, this is Teacher Marichu and welcome to our distance learning using MathPACKS for Grade 9, Quarter 1, Week 3, C. The goal of this module is for the learners to be able to convert rational algebraic equations into quadratic form and solve for the values of the required variable using the quadratic techniques in solving equations. To start with, we have the generalizations. Just go over it, learners. You have your modules with you. Then example 1 is done for you with ease. Then example 2 and 3. Let me proceed directly with the exercises to guide you on how to solve these 5 exercises. To start with, let's read the direction. Transform each of the following equations into quadratic equation in the form of ax squared plus bx plus c equals 0 and determine its roots. And we have to write your answer. You have to write your answer in your answer sheet. For number 1, we have 1 over x minus x over 6 equals 2/3. Solution, we have here, we have to identify LCD between x and 6 and 3. So in this case, LCD is 6x. So we have to multiply both sides of the equation by 6x. Multiplying such, we have 6 minus x squared equals 4x. Rearranging the terms, we have x squared, transpose it here, then have it plus 4x, then minus 6, equated to 0. Then we have here, we have to use the quadratic formula. We identify the coefficients a. For x squared, coefficient of x squared is 1. The coefficient of x is 4 and the constant is -6. So recall the quadratic formula, x equals -b plus or minus b squared minus 4ac all over 2a. So plugging in the values, we have x equals -4 plus or minus 4 squared minus 4 times 1 times -6 all over 2 times 1. So simplifying, we have -2 plus or minus square root of 10. So the answer for this number is x squared plus 4x minus 6 equals 0. And the roots are -2 plus or minus square root of 10. Moving on to number 2. 2 over x minus 3x over 2 equals 7. Solution, we have to identify the LCD of x, 2, and of course the denominator of 7 here is 1, so it's 2x. Multiplying both sides of the equation by 2x, we have here 4 minus 3x squared equals 14x. Rearranging the terms in such a way that we have the right hand side 0, we have 3x squared plus 14x minus 4 equals 0. Then, we use the quadratic formula. Let's identify the coefficients of x squared, x and the constants. In here, we have 3 for a, b is 14, c is -4. And plugging in the value, we have -14 plus or minus the square root of 14 squared minus 4 times 3 times -4 all over 2 times 3. So we have -14 plus or minus 244 all over 6. Then we have to simplify. What are the factors of 244 in such a way that one of the factors will be a perfect square so that we can take it out of the square root symbol? So we found that it's 4. So finally, the answer is negative 14 plus or minus 2 square root of 61 all over 6. But 14 and 2 and 6, we can factor this as, we can factor out 2 and 2 here in the numerator. So negative 14 divided by 2 is negative 7. Copy plus or minus. Then 2 square root of 61 divided by 2, that's square root of 61. Then 6 in the denominator divided by 2, it's 3. So the required answer is 3x squared plus 14x minus 4 equals 0. And the roots are written here as negative 7 plus square root of 61 over 3. And another root, negative 7 minus 6 square root of 61 all over 3. Number 3, we have 2x plus 1 divided by 4 is equal to x over 3x. Solution. LCD between 4 and 3x, then that's 12x. So we multiply both sides of the equation by 12x, giving us here 12x divided by 4, that's 3x times quantity 2x plus 1, then equals 12x divided by 3x, it's 4 times x. Expanding 3x times quantity 2x plus 1, we have 6x squared plus 3x, and transposing 4x here on this side will become negative 4x equated to 0. Then this can be simplified as x minus x. So we have 6x squared minus x equals 0. Then factoring out x, we have the linear factor 6x minus 1 equals 0. Then solving for x, we have x equals 0 or x equals 1, 6. But take note, once we got the roots, we have to verify with a given equation. In this case, the original equation is this one, and we cannot take x equals 0 as the root because it exists to be a root, but it's actually an extraneous root. It will give us an equation in which 1/4 is equal to undefined, which is a false statement. So we have, let's see, if x is equal to 0, substitute it here. 2 times 0 plus 1, that's 1/4. And 0 is here over 3 times 0 is 0. So 0 over 0 is undefined. So there is an expression 1/4 equals undefined, which is false. So that's the main reason why 0 is an extraneous root. Moving on to number 4, 3 over x plus 4 over 2x equals x minus 1. Solution. We have LCD again. So we have x and 2x. So we have to multiply both sides by 2x. Multiplying both sides by 2x, 2x times 3 over x, that becomes 6. And 4 over x times 2x, that becomes 4. So we have 10. On the other side, we have 2x squared minus 2x. So we transpose 10 here. So we copy 2x squared minus 2x minus 10 equals 0. Then, factoring out 2, we have x squared times, 2 times x squared minus x minus 5 equals 0. And dividing both sides by the constant 2, we have x squared minus x minus 5 equals 0. Then identifying the coefficients of x squared, x, and the constant, we have a equals 1, b equals negative 1, and c equals negative 5. Applying the the quadratic formula, we have minus b plus minus square root of b squared minus 4ac all over 2a. Plugging in the values for negative b, that's negative of negative 1, that becomes 1, plus or minus, well, negative 1 squared is 1, minus 4 times 1 times negative 5, all over 2 times 1. So we have 1 plus or minus square root of 21 all over 2. And the roots are given here. And the required quadratic form is x squared minus x minus 5 equals 0. Moving on, number 5. 5 over 4x plus x plus 2 all over 3 equals x minus 1. For the solution, we have the denominator 4x and 3, so LCD is 12x. So multiply each term here by 12x, and also the right hand side will be multiplied by 12x. Simplifying, we have x will cancel out. 12 divided by 4 is 3, so 5 times 3, 15. Plus, here, we have 12x divided by 3, that's 4x. So we just copy x plus 2 quantity, x plus 2 here, then equals, expanding this, we have 12x squared minus 12x. Combining like terms, here, we have 15 plus, expanding this, 4x squared plus 8x equals, copy paste here, then we combine like terms, 12x squared, we put it there, minus 4x squared, then we have minus 12x, this is 12x, then minus 8x minus 15 equals 0. Then we have 8x squared minus, combining 12x and negative 12x and negative 8x, that's negative 20x minus 15 equals 0. Why 8x squared? Well, we have here 12x squared minus 4x squared, that's 8x squared. Using quadratic formula, we have to identify a, which is 8, b is negative 20, and c is negative 15. Plugging the values, we have negative of negative 20, that's positive 20 plus or minus the negative 20 quantity squared minus 4 times 8 times negative 15 all over 2 times 8. So simplifying, we have 20 plus or minus the square root of 400 plus 480 all over 16. Then we have 20 plus or minus square root of 880 all over 16. Then we have to multiply 880, or I mean factor 880 in such a way that 1 is a perfect square, and we have 16 times 55. Then we have now 20 plus or minus square root of 16 is 4, and what is left inside the square root is 55 all over 16. And simplifying further, we have to divide this by 4, that becomes 5. Divide this by 4, that becomes square root of 55. Divide this by 4, that becomes 4. So the required answer is 8x squared minus 20x minus 15 equals 0. And the roots of this quadratic equation are 5 plus square root of 55 all over 4 and 5 minus square root of 55 all over 4. We're done with the exercises. We move on to the numeracy scales. Let's read the directions. Determine the missing numbers in the sequence And you have to write your answer in your answer sheet. So for number 1, 19, 22, 25. So what is the common difference in this sequence? So we have 22 minus 19, that's 3. 25 minus 22, that's 3. So meaning the common difference is 3. So we have to add 3 to 25, that's 28, plus 3, 31, plus 3, 34, and so on and so forth until we get to 46. For number 2, it's 16, 21. So what's the common difference here? That's 21 minus 16, it's 5. So that means 16 minus 5, it's 11. Then moving on, 21 plus 5, 26. Plus 5, it's 31, correct? Then 31 plus 5, 36. And so on up to 56. Number 3, we have given 22, 25, 28. Common difference again of 3. So 22 minus 3, that's 19. 19 minus 3, 16. Then 28 plus 3, 31, plus 3, 34, plus 3, 37, plus 3, 40, plus 3, 43. Here, number 4, we have 11, 13, and 15. 15 minus 13, 2. 13 minus 11, 2. So 11 minus 2, 9. Minus 2, 7. Minus 2, 5. And so on and so forth. Number 5, we have 9, 19, 29. It's easy. 39, 49, and so on up to 99. So long for this module, and see you in the next module. This is Teacher Marichu saying stay happy and healthy, and God bless us.